Hello, my name is Matt Ludwigs, and I work for a company called SmartRent. We build a custom IoT home automation platform for property managers and their tenants. And at SmartRent, I get to do nerves, and it's really fun. And we have custom hardware. And one of the things that we are trying to solve for is communicating to smart home devices, such as thermostats, locks, etc. So when you kind of dive into that field, kind of like Bluetooth, it's crazy, and so we have to go and handle our own library to do this. And so we're planning on open sourcing this library, and its name is Grizzly. So about Grizzly, it uses Z-Wave under the hood, which is a home automation low-frequency radio protocol for communicating and controlling these devices. What Grizzly does, it handles a lot of complexity of Z-Wave. Z-Wave is a very large specification with a lot of ins and outs and a lot of security things involved with it, so it automatically will handle some of those security things out of the box. It has an extensible command API, so if you send commands to these devices, and if you're using Grizzly and we don't support that command, we expose a Elixir behavior, so you can build your command, drop it into our library, and it'll just take it and run with it. It has error isolation, so we stole a page out of Phoenix's book where anytime, say you have a network of many devices, if you send a command over here and it fails, nobody else is going to have any issues, and everything will keep rolling. And it works with nerves, and so you can build your own smart home. So if you're kind of a hobbyist hacker and want to start building, all this complexity, all the hard stuff is hopefully solved by Grizzly, and you can build your own smart home. So, demo time. Can everyone see that? Okay, cool. So we have this smart lock here. The first, Grizzly. So we're going to list the nodes out here that are on our network, and there are none, so let's add this. Has nice audio.
Wireless module setting mode.
Okay.
Join the wireless network.
So we're just putting that kind of there, and then, so add node. I'm going to add the node. So right now the controller, so I have this Raspberry Pi 3 with a USB controller, is emitting, hey, join the network, and we're going to say, okay.
Completed.
So I joined the network. This runs in a, that was almost bad. It runs in a process and does message passing, and sometimes it takes a while because this actually is using some of the security complexities, these locks, and it should have received. So that's our node. It's now part of the network, so if we get nodes, we'll see that. And then there's the next API is get node, and the ID is 7. It returns, so get node returns OK. It's a tuple with an OK in the node. So I'm going to kind of not deal with that right now and just use this. And then, so we're going to connect to the node and establish a connection between our controller and this node. And a bunch of output. So interesting thing about IX, V, well, is the value of the last thing that was printed, so I'm just doing that, and then let's do something. So this next function is the main function that we'll concern ourselves with. And we're going to pass the node, the lock, the device there, and then we pass it a command. So we're going to get the state of the lock here. So it's unsecure, which is actually false. So sometimes this happens in hardware. Let's set, it'll fix itself. Let's set, so we can set the state. Thank you. Let's make it unsecured. Let's see if that, it unlocked. So that's like the main point of, that's like the main API that you would work with if you were building your own smart home. And I have stickers, and let me know if you have any questions.